Hello. In this video, we will explore Lumissil's Gen 3 capacitive sensing technology. Lumissil's third generation of capacitive sensing technology can be found in our MCU and touch key controllers. The technology can be used for making touch keys or proximity sensing. It marks a new milestone for detection, reliability, and low power consumption. The first benefit of touch keys is durability, since there are no moving parts to wear out. It also enables the creation of a modern, sleek look since it opens up new design possibilities. And third is cleanliness, since there are no crevices for dirt to collect and can easily be wiped clean. The benefits of proximity detection include energy efficiency. For example, in a wall or appliance mounted displays, there is no reason to leave it on unless someone is in front of it. Capacitive sensing can be used to detect when a body gets within using distance of a display, thereby saving energy. It can also provide enhanced safety on equipment. For example, a large industrial machine will not operate as long as a user's hands or fingers are near the cutting tool. Or the opposite is that a large tool will not activate unless an operator is present. Proximity activation is also sanitary, since a contactless gesture could activate a system such as a paper towel dispenser or faucet. Applications for capacitive sensing are found in appliances, automotive, industrial, ATMs, medical devices, and smart home devices. Next, let's review capacitive sensing basics. Its basic operating principle is that it detects a key touch or proximity event by measuring changes in capacitance of a sensor, also known as an electrode, when a conductive object like a finger or a hand approaches or touches it. Figure 1 is a side view of a simple touch key electrode on a PCB. The cover, PCB, and circuit for the baseline capacitance is represented as C1. When a hand or finger touches or comes near the electrode, the total system capacitance will increase and is detected by the capacitance measurement system. Although the operating principle is not complex, the circuit for measuring the changes in the capacitance is where the magic really happens. There are several design tricks Lumissil has developed over the years that prevent false activations from EMC or water droplets or other changes in the environments. Also, design tricks to ensure repeatable and reliable activations over time. Not all capacitive sensing blocks are the same, and you will find Lumissil to be a leader in this field. The third generation technology supports two types of sensing configurations: self-capacitance with an optional active shield, or mutual capacitance. Both configurations can be supported on the same MCU, but with separate pins. Self-capacitance has higher sensitivity and is best for touch keys. The circuit below shows a side and top view with a typical touch key button with an active shield. More about the active shield, though, in the next slide. Mutual capacitance is used for longer range sensing and is best for proximity sensing. It uses two electrodes, where one is a transmitter and the other a receiver. This configuration helps to improve the sensing distance. Pause here if you want to study the block diagrams. Now let's review the key features of Lumissil's third generation capacitive sensing. The system is higher in resolution compared to many of our competitors in older designs. This means it is more sensitive to smaller changes in capacitance. It can detect steps as small as 3 picofarad and a response time of 125 microseconds. It is lower power. In fact, we can boast the industry's smallest key monitoring mode is small as 5 microamps with MCU wake-up enabled. It also features an optional active shield, which will eliminate false activations caused by water droplets or EMI. And lastly, the third generation features self-calibration. This means over time, it will compensate for changes in the baseline capacitance caused by environment or material changes. Let's talk more about the active shield for touch key. Here is the top-down diagram again, but with water droplets on it represented in blue. Without the active shield, the capacitance of the system would have changed and could have caused a false activation. But the active shield acts to cancel out the water droplets. In simple terms, the baseline capacitance of the active shield and touch key change at the same time, so these changes can be ignored. When a finger touches the touch key though, no change is detected in the active shield and therefore must be a valid touch. This video demonstrates how effective an active shield can be for an application like an automotive capacitive touch door handle. Many older cars with capacitive touch door handles will lock or unlock the door when water is splashed on the handle, or it will cease to operate and try again. But as you can see, the system works regardless of the water. Another good example for Lumissil's third generation of capacitive sensing is touch key behind metal. For example, an appliance can put their touch keys behind stainless steel like shown in the Lumissil development kit in the picture. The diagram shows a side view and how these touch keys work. The stainless steel slightly bends under the pressure of the finger. The touch key is sensitive enough to even detect this small deflection even by a gloved hand. Watch the bars in this video as the user presses the buttons. Note as they increase in size, that's the key that's being pressed, and it is a clear difference from the other keys that are not being touched. Plus the user shows how touching buttons results in no of the bars rising up. And by the way, this GUI is a good example of our software development kit. Lumissil's third generation capacitive sensing comes in touch key controllers, which are pre-programmed MCUs ready for use in touch key and active proximity detection applications. No need for software development on your side. Pause the video now to review the table. Lumissil's capacitive sensing technology is also available in 8-bit MCUs as shown in the table below. This line of MCUs is very popular for embedded systems since they are very cost-effective. They come with built-in memory, lots of analog features, peripherals, and I/Os. They come in 2 temperature grades of industrial and automotive. Please pause the video to review the table for the best MCU to fit your application. Thank you. And that concludes exploring Gen 3 capacitive sensing technology from Lumissil. If you have any questions, visit us at lumissil.com or email us at marketing@lumissil.com or follow us on LinkedIn and Twitter. Thank you.